All right, so today we're going to continue working on our quiz review packet. Tomorrow we're going to start the next units, 5.1, and then Monday we'll continue 5.2. Obviously, these will not be on the quiz, but your quiz will be next Tuesday. But even as we're going through a new set of notes, we can still have the second part of class to continue reviewing. So I'm just going to continue picking up problems, even if we're done with the quiz review, for us to practice Friday and Monday in class, and your quiz will be on Tuesday. Help session Friday morning and Tuesday. So tomorrow morning and Tuesday morning. Friday's more if you have specific questions or you want me to go over specific problems, and Tuesday I'll have a morning review for us to do. Did we finish? It says 7 here, page 7. The volume and surface area problem. Okay. Did we start it? We did start it. Okay. Can I just come around and just check pages 1 and 2? We did that in class. I just want to give you guys credit for that. And then we'll pick up with page number 8. Okay. But go ahead and start page number 8 as I just come around.
I think we did number 8 yesterday.
We did.
Where is he? Something I actually did. We were really just applying to man and looking at what. It's like what? I don't. How can you exactly get all the
27. You want to do like
yeah. I know.
Oh well. And then I don't care. I just start over.
Yeah, all that one is free. No, I'm really short. Because I'm trying to understand, you have the most concerned part in the so I, yeah. Oh, is that great?
Yes. Everybody else. Yeah. Like more. Yeah. Yeah. Thanks. Nice. Nice. I'll be so good. I'm scared.
Been doing pretty decent.
Yeah. Hardly that's part of be great.
Okay.
Can I look at it?
Did we finish going through number 8? We did. Okay, so no questions. Everybody okay with number 8? So you're just building your volume and surface area formulas, and then you're just derivatives, and then you're just plugging in and finding your missing variable. Okay. So everybody good with 8? All right, let's go to number 9. Number 9 is a Pythagorean theorem problem. I'll draw the diagram for you here. So we have jet A. Headed towards St. Louis. And then we have jet B from the south headed towards St. Louis as well. And then there's our right triangle that's forming. Okay. X, Y, and so. What's happening to this triangle as time passes? It's getting smaller, right? So that's going to affect all of our rates, right? So all of our rates will be what? Negative, right? So it makes sense, right? As the 2 jets are headed towards St. Louis, the distance X, Y, and Z are all going to start decreasing. So we're going to be expecting all of our rates to be negative. All right, so start there. See if you can build your Pythagorean theorem, find your derivative, list out your 6 variables, and start assigning values. See how far you can get.
Well, the miles per hour won't be.
The miles per hour is the rate. So you want that to be a negative because the length of the triangle is decreasing by that miles per hour rate.
All of the rates negative.
That's right. All the rates are negative. Yeah. Yeah. Thank you. So X is 100. 100 at this moment in time. Jet A is 100 miles away from St. Louis. At this moment in time, Z, the distance between the two jets is 200 miles. Pythagorean theorem gets us that Y value going to be a decimal value. It's not going to be as clean as just 100, 200, 300. So we have to find that Y value using the Pythagorean theorem. Dx dt, we know that's how 500 miles per hour is how fast the jet A is moving, but it's causing that distance to decrease. So that distance between jet A and St. Louis is decreasing by a rate of 500 miles per hour. The rate, the speed that jet B is closing in on St. Louis is that distance is decreasing by 600 miles per hour. And then we should have only one missing variable to solve, and that's dz dt. Right, any questions? Right, let's look at a shadow problem. We haven't done one yet, so we'll do that together here. Okay, we're always going to start off with this diagram here. And you're just going to fill out the vertical constants. Man is 6 feet tall. Street light is 16 feet tall. Okay, set up your proportion. Small base is to big base, or small height is to big height, as small base is to big base. Make sure you remember it's y over x plus y and not x over x plus y. This is going to be easier than the cone problem because even though this is a similar triangle, this is the equation that you're using. Okay, there's no need to substitute this into another equation. You're just cross multiplying, combining like terms. It should be a relatively easy equation for you to find the derivative. But when you find the derivative, the dx dt will show up and dy dt will show up. All right, go ahead and find your derivative. As a reminder, what each of these rates mean. The rate of change of the person walking is dx dt. The rate of change of the length of the shadow, that's dy dt. And then the rate of change of the tip of the shadow is adding the two rates together, dx dt plus dy dt. And there's also extraneous information that we don't need. The fact that he's 10 feet from the base of light is not going to matter. Right, so see if you can gather your information, find the rate of change of the length of the shadow, and then find the rate of the tip of the shadow. And really, the only equation you need is this one here to try to solve for your missing variable.
When we're answering like part, do you want us to like just write rate of change of the tip equals?
That's fine. Yeah. Dx dt is going to be -5 because the person is walking towards the lamppost. That's causing the x to decrease. So that's our starting point. Put that into your derivative equation, solve for dy dt. Dy dt is a -3. That it will help you figure out the answer for part A. And then part B is the tip of the shadow. You're just going to add these two rays together, -8. Oh no, the triangle is getting smaller. Let's say here's the light source, right? If the person is standing really close to that light source, the shadow that's going to be created is going to be relatively small. But if the person is further away from the light source, he's going to create a longer shadow. So as X decreases, Y is going to decrease. As X is increasing, Y is also going to. Okay, any other questions with shadow problem? All right, next page. Okay, we're back to a cylinder. What's the key thing to remember about the cylinder?
Radius.
Radius is constant. Yeah, get that radius to be replaced, and then you're ready for your derivative. And then just also be careful of extraneous information. There's going to be information that's going to be good for cones, but we really don't need for cylinders.
But when the containers that full, that's the extreme.
That's extraneous, yeah. And also the height of the container is also extraneous. We don't need that either.
So we're allowed to break
Say it again.
I think we're allowed to keep our answer like
Yeah, leave your answer in the exact form. So anything dealing with pi, I want to see that pi in your answer. Okay, the next two are Pythagorean theorem problems. If I give you a Pythagorean theorem problem, I'm going to draw the diagram for you on the quiz. Any questions with the cylinder? Try 12, and you get done with 12, go to 13. After we get through this page, I wanna put a cone problem up on the board for us to practice. I want us to do a cone problem each day, because I know that's the type that requires most practice. 19.209. Knots per. We do have to find the X and Y values on our own because of the fact that it's asking for a moment in time that is not at the beginning of the problem. It's after 2 hours. So after 2 hours, the boat that is traveling west is going to cover a distance of 24 knots. The boat that's traveling north, going at its speed, is going to be 30 knots away from the starting point. So we're going to use 24 and 30 as your X and Y, and then use those to get to the Z values and put that in here. Any questions with 12? Okay, 13. So here's a diagram for 13. Man is driving north, and then he sees a railroad track up ahead. And then there's also a train that is moving towards the east. There's a triangle that's been formed. What do you expect from dy dt? Negative, okay? Even though it's going north, but the fact that this side, that vertical side of the triangle is getting smaller, so that rate is negative, but dx dt is what? Positive, yeah. That side of the triangle is getting longer as time passes, so that rate is positive. So dy dt should be negative, and dx dt should be positive. Page 13, can you try number 1? And then after that one, I'll have a cone problem for us. So do the volume and surface area of a sphere problem. Page 13. Here are the formulas. Volume is 4 thirds pi r cubed, and surface area is 4 pi r squared. Page 13. Okay, find your DRDT first. Once you get your DRDT figured out, then you can use that to find your DSDT. Okay, take the 25 cubic feet per minute in for dVdt. You have the radius, which is 8. Use that to solve for DRDT. Once you have DRDT, um, and then use that to help you get to the real variable that you're looking for, which is DSDT. All right, here is the cone problem that I want us to try. If you guys can just find a separate sheet of paper to write this problem down. Everyone okay with this here? Uh, Cone cup is 4 centimeters across, 6 centimeters deep. Water leaks out of the bottom at a rate of 2 cubic centimeters per second. How fast is the water level dropping when the height of the water is 3 centimeters? I'm sorry, a cone. So you have a cone cup. Right, set up your proportions. Figure out which variable you would like to keep, which variable you would like to replace. And also careful with the fact that this 3 centimeters height is not to be used at the beginning, right? This is going to be saved until the end. So your proportions should look like this. R over 2 equals H over 6. Cross multiply, 6R equals 2H. The reason that we know that we want to solve for R is because our hint is that we're trying to solve for dHdt. We know dHdt is related to H. And if we want our H variable to stay, that means the radius is going to be replaced. If I want to find a replacement for R, I'm going to solve for R. So I can find a replacement for it. So my R equals H over 3. That helps me guide me to my next step. Once you're here, make sure that you spend time to clean up. So distribute your exponent through both your parentheses. Combine all your H's together, merge your fraction together, and now you're ready for the grid. Now I can do your power rule. Okay, I'm gonna leave this up here on the board for another minute, but last problem, page 13, bottom of the page, number 3. Another Pythagorean theorem problem, but then part B is way to change the area of the triangle. So number 3, page 13, and that'll be the last one for today. Page 13, number 3. Any questions with the cone problem? Page 13, number 3.
We'll get our tests back.
If not Friday, then Monday. Okay, so we have to adjust for the fact that the distance is coming after we make some calculations. This is 2 hours later after they started moving. So 60 miles per hour after 2 hours will be 120 miles. 25 miles per hour after 2 hours will be 50 miles. So if you have X and Y, you can find Z using Pythagorean theorem. Both dxdt and dydt are positive because they're both causing the size of the triangle to be increasing. So we put all that in. dcdt is 65 miles per hour. Part B, find the rate of change of the area of the triangle. So area is 1/2 x times y. Go through the product rule. And then put in all the data from part A to get your dAdt. Square miles per hour. Area is square miles. Time is hours, so it's square miles per hour.
So, yeah, man. Wow, you get a lot of air. Yeah, no.
Okay, no homework tonight. I'm just gonna be checking pages 7 and 8 tomorrow, what we did in class. Tomorrow we'll start our next unit, but we're still gonna have time at the end to just continue with practice.
So it's fun.
Yeah, because we lay on the floor.
Yeah.
You were way down. We're like 70%.
Your foot.
I know, but like, we'll get Fulton County, if you're gonna win the numbers, there were. It's numbers, but well, it's like, all right, 70%. Then they're gonna say, oh, no, I'm one. I used to stay in.
That could be.
Well, no, next day it's.
Like, oh, I don't see. It's like five size, I mean, it's also like five size, I do it, it's just like.